So let's do this problem, and it's going to be a bit more difficult than before. So what we're given is as follows. We're given this force vector F, but only the magnitude. And we're given some angles. We're given that the projection of this force onto the xy plane is 30 degrees from the x-axis. We're also given that this angle right here is 40 degrees. Okay? So those are the information that's given. What they would like for us to find is the Cartesian vector notation for the force F. So that's what they want. So the solution. In order to do the solution, you have to understand what this means. Well, Cartesian vector notation for the force vector F just means that they'd like for us to express F in terms of its x, y, and z component. So how are we going to do this? So let me explain, and then we'll do the math. The x, y, and z component of this force vector F lies along here. Okay, so we need this vector right here. Okay, that's F of x. We also need this vector right here. That would be F of y. And we need this vector. That would be F of z. So we need those three. We don't have the direction cosines, so we can't use these formulas that I've been asking you folks to memorize. But what we need to do is manipulate some of this data to the point where we can use these formulas. So let's see how we go about manipulating it. What we want to do is first find F of x. And simply, what that means is that I'm going to project this onto the xy plane, which gives me a right triangle. Given a right triangle, I should be able to find the length of this side of the triangle. Let's call that F prime. So if this is F, we'll call that F prime. Once I find F prime, I form another triangle or visualize another triangle. And for that triangle, it's 90 degrees here. So I have another 90-degree triangle, which allows me to use Pythagorean Theorem because I know this included angle between this side and this side. I should be able to find F of x. Likewise, for F of z, because vectors can translate, it would be equivalent to me finding the length of this vector, or I'm sorry, the length of this side, which I can do because this is a right triangle, and I can use the Pythagorean Theorem using this 40 degrees to find this side. And finally, to find F of y, I would use this triangle right here, where it is 90 degrees here. And I'm going to have to find some angles here. For example, I'll have to determine what that angle is, which we know. Because if this is 30, then this is 60 degrees. So therefore, I have a right triangle. I should be able to find F of y. So let's go ahead and do that. So the first one, I want to find F prime. That would mean I am working with a triangle that looks like this, which would be this triangle right here. That would include that 40-degree angle, so it would look something like this, where this is F prime, this is 40, this is 50 newtons. Therefore, cosine of 40 is equal to adjacent over hypotenuse. Therefore, F prime is equal to 50 times cosine of 40 degrees Newton. And that would give me a value of 38.3 newtons. Next, now we're going to use this triangle to find f of x. So f of x is equal to what? So it's actually working with this triangle where this is f prime. This is that 90-degree right there, okay? And therefore, this is f of x, and this is 30 degrees. Therefore, cosine of 30 is equal to adjacent, which is f of x, over the hypotenuse, which is f prime. And we know what f prime is. Therefore, f of x is f prime times cosine 30 degrees, where f prime is 38.3 newtons, times cosine of 30 degrees. That gives us a value of 33.2 newtons. And finally, and now for f of y, what is that equal to? That's equivalent. Now for f of y, what is that equal to? We need to visualize this triangle, this right triangle, and it would look something like that, where this 90-degree angle is the same as this 90-degree angle here. Therefore, this is f of y. This hypotenuse is f prime. And this would be 60 degrees. Therefore, cosine of 60 is adjacent over the hypotenuse. So fy over f prime. Therefore, fy is equal to f prime of cos of 60 degrees. F prime, we've already figured out, 38.3 newtons times cosine of 60. That gives a value of, let's calculate that. That gives a value of cos of 60 times 38.3, 19.2 newtons. And finally, for f of z, we can use this triangle and this angle 40 degrees, and it would be equivalent to looking at a triangle that looks like that, where this 90 degrees is this 90-degree triangle shown here. Therefore, this would be f, this would be f prime, and this is 40 degrees. So what we have is we'll take the sine of 40 degrees, which is equal to the opposite, which is fz over the hypotenuse f. So solving for fz, I get f times sine of 40 degrees. And calculating that, where f is 50 newtons times sine of 40. So 50 times sine of 40, that would give a value for the z component as 32.1 newtons. So the Cartesian vector notation is then given by the following. So f is equal to f of x, which we found to be 33.2. And by looking at the figure, we know that it's pointing in the positive x direction, right? So f of x is in the positive, and so are fy and fz. So we can now say that it is a positive 33.2i plus a positive 19.2j plus a positive 32.1 k Newton. And when you write it in this form, this is the Cartesian vector notation for F.